Our project is based on this data, the World Development Indicators. We took the data set from the data bank of World Bank. So it's called EcoTrend World Development Indicators. Our basic aim is basically that we wanted to get all of this data for all the countries in the world and sort of analyze why certain countries are developing at a faster rate as compared to other countries, despite some countries having a very large population. So when we just downloaded this data, and this data basically looked like this. We had the indicators, we had all the years. So this was not fitting our criteria. This was not in the format that we wanted. So we had to do a lot of cleaning and dealing with missing values. Jiske baad, what we did is we transposed the data and made it into something which looked like this. So this data that you're seeing is basically we converted all columns into rows. और ये हमने किस तरह किया है? So I did it through EDA. We were supposed to do it in the container, but we could not. So we did it through pandas. जब ये डेटा हमारे पास आ गया, इसको हमने, this is 1.8 GB of data. All countries, there are 266 countries that we have and 1478 indicators. इसमें से I selected 34 very important indicators and made another final file which looked like.
Our project starts with the Docker Compose file. It creates the 4 containers: Redis, data ingestion, Spark Master, and Spark ML. The Redis container is the database container for this project. The second container is a data ingestion container. It reads the CSV files, cleans the data. That is, we have the data set as follows. We have the countries, the indicators, and the years. Now, we have chosen only the years from 2000 till 2021, as the previous year didn't have much of the data. Okay. The unnecessary columns are dropped, and the null values are filled in with the average values, and the values are stored in the Redis. Now, the data is stored as a key value pair. There are 3 types of key value pairs. First is the country, where the country code is the key and the country name is the value. The second type is the indicator, where indicator code is the key and indicator name are the values. The third type contain the year values. It have the composite key. The first part is the country code, the second is the year, and the third is the indicator code. The third container that we have is the Spark Master container. This is the prerequisite for the Spark ML. The final container is the Spark ML container. It contains the entrypoint.sh file. This file makes sure that the data ingestion container have completed its working before the Spark ML containers starts. Now it have the regression.py file that applies the machine learning techniques. It reads the data from Redis. Then it creates a data frame for the set data. It drops the unnecessary columns, and it applies the gradient boosting to the data. The final thing that it does is create a pickle file that could be used later for the visualization. This is the output that I get when I read the Redis data in the Spark ML container. This is the data after encoding, and these are the predicted values.
Now this file is based on some indicators which we selected for our analysis because हम data analysis कर रहे हैं. So these are education related indicators, these are socio-economic, these are financial, and these are education related. उसके बाद we started working on HIVE. So HIVE में हमें बहुत time लगा इस data को पूरा load करने में. So you can see I've loaded all 1.8 GB of data. First हमारा data load नहीं हुआ, उसमें बहुत issues हुए. Finally हमारा data correctly load हो गया once we reduced the size of the data. So you can see all the data of all the countries is loaded. अब इस पे we are running some analytical queries. So our main aim is to see first the population trend. So now we can see if over here the population trend is that China has the highest population, and then India, USA, and Pakistan. Despite Pakistan having the fourth largest population, it's still underdeveloped. So our aim is to analyze why is Pakistan underdeveloped as compared to other countries, even though it has such a large population. And so अब हम curiously click के इसका analysis करें based on education and GDP and imports and exports of why are some countries developing, why are some countries not developing, what are the crucial factors involved, what's the percentage of female population, what's the percentage of male population, जैसे कि नजर आ रहा है आपको. And I'm going to also create partitions and buckets in my data, so for faster querying. And all of this is done, and results of all queries are being recorded. Now my aim is that once we are done with the analysis, we are passing on the analysis to our other member Uruj, who is going to visualize it. So our main dashboard is basically going to show trends, indicators that we have selected, जो हमारे मुताबिक important हैं, और जो हमने countries select की हैं उसका हम analysis करना चाह रहे हैं that why are these countries developing or not developing.
We used PowerShell to run our Streamlit app. Our Streamlit-based dashboard provides a user-friendly interface for exploring and comparing the development and economic indicators of different countries using the World Bank data. Users can leverage two visualization options, a bar chart and a line graph, to gain insights into these indicators. Focusing on the GDP trend of United States and China. Over the past 5 to 6 years, the bar graph enables a clear comparison of GDP values during the selected time frames. The line graphs featuring a secondary axis for easy comprehension provides a visual representation of historic data, offering valuable insights into the growth and changes in these economies. One compelling observation from the visualization is the remarkable upward trajectory of China's GDP, which has surpassed that of the United States. This trend showcases the substantial growth of China's economy in recent years. To further enhance our dashboard's functionality, we integrated regression models capable of predicting indicators for 6 years. For example, users can forecast South Korea's GDP for 2024 by selecting the country indicator and desired year. The regression models fueled by encoded features such as country code and indicator code generates accurate predictions. By clicking the predict button, the selected features are passed to the model, which generates a prediction based on the historical data. These predictions empower users to make informed decisions and projections based on predicted indicator values. A user-friendly dashboard facilitates exploration, comparison, prediction of country-specific indicators. By combining intuitive visualization with predictive capabilities, we enable users to unlock valuable insights and support data-driven decision-making. I will show the back-end code which is running this dashboard.